Thank you guys. I'm Mr. Lord. I'm going to teach you some program. We've been here before. And we're going to teach y'all a lesson on quadratics today. So, first we have a little video for y'all. Is he alright? Alright. So, at the beginning of the video, when the ball was bouncing by itself, what did it kind of look like to y'all? Did it seem right? Did it look kind of off?
It looked off.
Yeah, it looked a little off, right? So let's pretend this is our ball, and let's kind of imitate what happened at the beginning of the video. So say this black square right here is some kind of like motion detector that reads how high the ball is at any point. So we start at 0, which is like, it'll be 0. So times 0, you're on the ground, right? The ball comes up slowly and kind of comes back down at a very constant rate. So look on your desks, and y'all should have little graphs. So kind of graph what you think the graph would look like if your x-axis is time and your y-axis is the height of the ball at that time. So, and once I get that out, I'll kind of do another representation and kind of like count through it. Maybe a little better example.
The one that says predict the graph, that's the one you're supposed to use.
Yeah, there's 2 of them. There should be 4 copies of one that says predict the graph and one that's just a x and y axis. Doesn't have the title on it. The one without the titles for later. So put that back under the other words and stuff. Okay. So let's look back up here. So we have our ball, right? So let's count out the ball as it's going up in the way it did at the beginning of the video. So it starts on the ground and it goes 0, 1, 2, 3, 4, 5, 6, 7. So in that 7 seconds, we're like 7, just think of it like 7 x values, where would the height of the ball be as it comes across that graph? So go ahead and sketch that out on the paper real quick. Okay, has everybody sketched it out?
Yeah.
Cool. Someone go ahead and, let's call someone who's good. Anthony, go ahead and hold up what you drew for your thing, and I'll draw. Let me, so I can see. I'm gonna draw on the board. Okay, so Anthony drew it like this, on a straight line, right there. Does everyone kind of agree with what Anthony said? Yeah. Thumbs up, thumbs down. Can I get a? Yeah, everybody good? So yeah, the way the ball was bouncing at the start of the video, that's right. But as we saw, I guess the bag of beans was trying to tell the ball, it didn't look fluid like it should. It looked kind of strange. So what would a ball that's actually bouncing kind of look like? So say we took the ball from here, say this is at like 5 feet or whatever, and we dropped it. What do you think this graph would look like? Go ahead and plot it. Try to use just like color it in darker. And just kind of like if you drop the ball from about 5 and just let it bounce naturally, like it would normally. We're going to sketch out what y'all think about that. Alright, so everybody have a second to draw. So someone, Celeste, go ahead and show me what you got for the new ball. How that looks fluid. Just show me the paper. And there you go. It's a little bit, alright, so she drew something like this. It's a little bit along these lines. So the ball started here and kind of went up like this. So if you look at this graph and that graph, are they kind of the same, right? But this one's as if it was dropped, and this one's as if it came and kind of comes back down, right? So, but since, as we decided on this one, it didn't look quite natural, right? So does anyone else have another representation of it that they want to use to represent it? Anybody? Different representation other than kind of a jaggedy thing? You have one? Let me see. There we go. I like that one. So he drew, Jonathan drew something that looked a little bit more like this. Ball starts here and it kind of. Okay, this is a little lower, but you'll see the difference right here. This is kind of a more, so you're almost studying quadratic functions for the last couple weeks, right? Doesn't these kind of look like quadratic bumps, even though they're kind of poorly drawn, right? So that's what we're trying to get across is, like gravity, when it affects an object that's bouncing, it kind of slows it down and then speeds it up, and then slows it down and then speeds it up, which is different from a little more jagged, or how the ball looked at the start of the video. And then the beanbag was kind of like, now you gotta bounce like this, dude. And then that kind of thing. So we're gonna go into, we're gonna explore some real-world quadratic functions and where we see them. So go ahead, and y'all have a calculator, a baggie with a question and a bunch of little tiles in it, and a blank table at y'all's desks. So, and then everybody look under your name tent. You should have a number on the name tent on your desk. And everybody know what the number is, and the number has a different job. So remember what your job says. Alright, so everybody remember their job? Give me a thumbs up if you remember what job you're on, right? So these are what you're in charge of for each job. So what we want you to do, okay?
Number what?
Are we good? Alright. So these are the jobs and like the descriptions, even though some of them are kind of self-explanatory. So what I want y'all to do is look at the question. One of y'all will graph it on the calculator, and then one of y'all will draw it on the coordinate plane that we gave you that wasn't the one for the prediction, the extra one. And then we have a bunch of questions on that table, a bunch of little like elements to identify, and then what they are, and then how they kind of relate to the real world on that graph. And then, so calculator manager graphs on the calculator, sketch artist draws it on the graph, the matchmaker kind of like is the one in charge of putting the cards where they go, and then the mediator is if two people think that a card goes in a different place, they kind of like decide and help decide that. So y'all go ahead and we're going to give y'all 15 minutes to do that, and I'll be walking around.
A bicycle is right as 20 miles per hour, which starts turning around. The distance y that he travels can be modeled by the function y equals y that requires the time in seconds. So the first one here is the bicycle is when time is 0 of the direction. The is 0 to infinity.
That's too much time. That's too much time. Because then there's how many much more minutes are in different.
Oh, that's supposed to be a 25-minute explore. I ran a little over on the.
Okay, just make sure that you give them plenty of time for the evaluation because it's 4 questions.
Okay. Class in. What time is class in today, Mr. Burris?
10 till. No, 5 till.
5 till?
These are the times in which cycles
So we did give you a
warning.
Let's go to the 10-minute explain.
Here doesn't mean anything. X is 3 of 2. values you made, I think, in this instance.
Wait, so what are we trying to find out?
16. Where is x is time in seconds? Y in
X
seconds.
is distance.
D is the starting point. It's where they launch the rocket from. Did you graph it on the calculator? Do that, and it'll give you a
There's
little
supposed to be 2 of these.
graph, and it's kind of height versus time. This one really relates to the ball. The other
Oh,
one,
wait, never mind, there's no main.
Yeah.
I graphed this one.
I want to get him now. Yeah. He's following.
How about we don't erase?
I want to take this thing home.
Wait, I just had a graph. I didn't even saw the graph.
Wait,
We have three.
yep. Okay, well, some of them, so if you look at the, so you have the values, right? This. Some of them, so the bicycle starts here, you graph the graph, right? Go and graph the graph.
Which one is it? I know, but I'm looking at the
Oh, did you hear her?
Yeah, I'm like,
See the function of your graph?
I was like, yes, I want it.
No, wait. That's right. Okay.
I had it on there. I'm not.
I grabbed it for you.
Alright, let's see where it goes.
Is this back on the
Value of. Value of
So anyway, so you go there and you go to like things like say the vertex. So what's the vertex on the graph? Is there a way to find vertex? Go to the table. You don't have to find what the vertex is. You're not gonna square it. Let's go to where on
I didn't do it.
What's the question?
The settings?
Yeah, the settings, did y'all have it like that on purpose?
Let me see. Did he do it before?
So you see how I have that point there?
I don't think
Point
so.
is,
He said that he did something.
if you look at it, so you look at these, right? What's a point that would look like that? Yeah, the vertex. It's a bit more down there. There you go. So you see you have -2, -3, right? So that'll be your vertex. So look at the context of the rule. A bicycle is traveling at speed of 20 miles per hour and starts running down a long hill. Distance y during the travel.
Oh my gosh, I was
can
gonna
be
do
involved by the
this.
function
I mean,
pi x squared plus 20x, where x is the time in seconds. Well, obviously, it's not going to go back -2 seconds and start then, right? So that's one of the things where, in this instance, the value doesn't mean anything, because if for some reason, like you started at say -5 seconds, you would start from that point, but you restarted at 0. So this one has like quite a few of those. So there's a lot of them that in the graph they would mean something, but in our little window that we're looking at, it really doesn't.
Max is job.
They'll identify all of them.
Hey, Mom.
The calculator. Y'all can sketch the graph, or is it? I'll come back to you in a second.
It was a parameter. Wait. No, it's not. It's gonna be -4.
So basically what you want to do, go into the calculator on,
Oh, wait.
go to y equals, and then this graph,
Y is
use
0.
the calculator. So you
We have to explain these.
plug this function into the calculator, and
So
then
this one,
going to,
wait. Y is where the bicycle is.
and then going to the graph, giving it, passing over the sketch artist rule. Wow, so like you see better.
It's
Like, I'm sorry, I
Look
can't
at this
help.
graph, and so you go to this, right? So corner's the vertex. Where's the vertical? Actually, first, before you do that, who's the scale? You are. Okay. So what I want you to do is kind of draw this out so everyone can see it physically. Kind of draw it out on your graph. Yeah, I'll just kind of draw it. I got about 8 minutes left. Sounds like that, right? So where on this picture is the vertex? So the best way to find that out is what is the vertex, right? Trace it up to about the vertex and then find a little point like this that has the
Like that.
Try hard.
Okay, so basically, just look at the graph.
yeah.
I mean, that's how
Go ahead and put that on the table. So then, so you look at that, right? This question is kind of complicated because X value is really like the length of one side of this rectangular card.
Yeah, it's something like that.
Wait, I'm gonna explain.
You have 8 minutes to choose a small rectangle.
Alright, what is the
Region for a dog pen. So the area of the region can be found by the Y value.
Domain of what?
And the length of
X value
length of
negative 2 to 5.
length of the length is the X value, and then the width is just kind of going along how I get with the rest of the meters. So
And the Y
this is basic Y right here at the top. What does that mean? So since
oh wow.
this is an area, what would be the vertex in like real?
Okay, yeah. Okay.
So like this is the number that you get for your Y value is your area of that graph with this particular vertex. So the vertex, what would it be in terms of like
I'm not the only person.
it would be, so this is the area, right? Whatever your number is.
You know, I think it's a good thing that it's cut up.
So with that length.
They wouldn't got it writing it down.
It starts at the point 0.
I think you should better.
Area of your graph.
One of it fully filled out, like fill in the blanks kind of.
This is changing the length.
That's what I had in my mind. We have like
Your area is changing your Y value, right? So since this is the highest possible
that would say
value,
no.
The slope.
yeah, this would be
It's like
that is the one that has your vertex.
He zoomed out.
Something I said is the maximum area.
the axis.
The length here is 20 is what it is. The area is some of them will like have like little things like
What is the axis of symmetry? Yes. What is the axis of symmetry? What's the symmetry? What do you mean with it? What is the axis? What do you mean the vertex is? You said when they line up, but then what are these?
Are you linking these up? Don't forget about your
Not just hit graph.
Bicycle starts at
don't forget to click
1
down on the table. This is like, see here you have it
This
as
is
the high maximum energy button there. Which one of these would that be?
Is there one that says 0?
You see if you're bumping under way. Go ahead and do that. Highlight that over here. The axis of symmetry? Okay, so the axis of symmetry is kind of, it's a line going through your vertex that kind of cuts the graph in half.
Why is that
And so
there?
in this case, so your vertex is like 20,
So put this here.
400. So what would be the x value for all the axis of symmetry?
Wait, looked
Okay.
at the wrong one.
Okay. Take time to process this.
So it'll be
Say this earlier, no? Not that one.
this all x equals 20 here, right? So that would be the x. And then the range would be something. Yeah, the other one.
Fish. 3.
Okay, so you know how you kind of like represent it like this. That's the way.
No, 3.
So like if this was the domain of the region, negative infinity.
See, there was an A
So
dispute.
these, there'd be one like that and another one.
We leave us all.
It's the word X, right?
Then
The maximum.
regular, this one like describe like what the real terms of it.
And these are the minimum.
So you'll have like
X and stuff.
How are you?
Y and
I am not troubled.
yeah, this one.
symmetry.
Y'all, I'm following y'all's real world.
Axis of symmetry. And these are also the minimum.
This right there.
The minimum. Well, without graphs, but with giving, yes.
Matchmaker.
Yeah, because we're in real time.
Are y'all done?
You get me? We're in real time.
Okay, you were wrong about that one, Alexis.
I know. Back to my drawing.
I put it there. Who
I
moved
told
it?
you.
Who moved it?
You'll see lines though.
Yeah. Did the dispute like
It's between me and Michael.
y'all moved it? I had it right.
It needs Maria.
Oh, it's about 2 minutes, so y'all have, so try to pair as many as you can, quickly as you can. And in a little bit, we're gonna present some of them and kind of show what we've gone through. Discuss them.
That's what they had done.
Pretty good.
With money.
My name is Mike.
They put his face on there. They put his face right here. But it showed up.
Yes,
Somebody
Michael.
that
My own name.
look, it was like this.
And actually, are there any just 45 minutes?
So why does he have two in hand? Are we trying to decide or are you done? Who's helping him? Okay. What do you have?
They had his face on there. It's why like that's why I thought
How would you go I don't care.
Where did you come from?
Let me see those two other
Time rocket was on the ground.
This one moves too much.
He wants to stay. Where are you gonna go to? Why do I have to prize for Michael?
No, he doesn't.
With the wine, add wine.
Why?
Why?
We're gonna miss it.
Alright.
So, you want.
That's symmetric one was 20. Axis. Let's see.
Michael, really?
Wouldn't that be the domain?
Oh, that was the turkey.
I'm still.
That was the turkey, so go ahead and grab the Okay, so we're gonna have a couple of y'all come up and present what y'all found for these functions. And hopefully we can get a good explanation of
So what space looks like.
So we are going to,
This is space.
awesome. So now we finished all the problems. We're going to have a couple of y'all come up and present some of the solutions y'all found as a group. And we'll talk about, and we'll have them present the real, how it pertains to the real world and all that stuff. So can y'all in the back come up and do problem 1? And some of y'all have the same problems as this group, or one of the groups will have the same problem as this group, and some of y'all have a different problem. So just kind of walk through quickly your thoughts and reasoning between all of them, and bring up your sheet if you can. Put it on this here. Try not to like drop your pieces though.
Domain is not
I hit it once to turn it on, right? Projector?
Yeah, once turn on.
And you're gonna be recording.
I have another one.
Okay, guys, so everyone please give your attention to Jonathan, Jose, Justin, and Maria. Maria?
Yep.
Yeah, okay.
Becca, what's the far light, please? Far switch?
Sounds
That's what I'm talking about. Thank you. Let's say hit the auto, there you got it. Now autofocus.
Is that, is it, right there?
There we go.
It focused on.
So go ahead before y'all start, read y'all's problem at lunch.
Okay, I'll read it. A model rocket is launched from the top of an observation tower that is 64 feet high. The height of the rocket, ht, is determined by the function ht equals negative 16t squared plus 48t plus 64, where t is the number of seconds elapsed since the rocket was launched.
Basically, it's saying that a rocket was launched from an observation at the vertex of 0 and 64, not showing where it was launched. And it's
Correct y'all real quick. Y'all have these two.
the 64.
Yeah, it was launched at that point. But, so, the vertex, think about the graph, the parabola. It looked something along the lines of, I'm going to go ahead and redraw on this one. It looked like this, right? So it started at 60, we'll continue going on this way. But it started at 64, went up, then up. So where's the vertex on this parabola? Right there, right? So is this at 0.64? Because you'll have the 0.64 and its explanation right, but you'll have that mixed with a different on the thing. Can y'all see where y'all did there?
Yep.
Yes, actually, the axis of symmetry, what you have there, that would be the vertex, right? Because that's at this point at the top. And then, excellent. Don't forget to bring the explanation with it, because that's also correct. The explanation is just No. You had this one with it? No, that's correct. So that would be for axis of symmetry. And the y. Alright, so think about it. Okay. What are y'all saying about y'all used the right description for that point 0.64, which was launched from. Where was it? Oh, the height of the rocket was okay. That was with it, right?
Yep.
So y-intercept, so that's when your time is 0, right?
Yes.
And you were launched from a 64-foot tower, correct? So that would be your explanation for the y-intercept, correct?
Yes. And as you said before, the vertex would be the highest point, which also goes along with the second one where it says the maximum at y equals 100. So that kind of gives a hint showing that it would be 1.5, 1.5, and 100, even though I didn't know it's it. And For the x-intercept, as you can see, it's the only one that's marked with 2 points that have no y, or the y at 0. The axis of symmetry, I'm guessing that's the highest point, which the line goes through it. Symmetric points, I do not understand.
Symmetric points. It's like where both your y coordinates are the same, and as you can see, they're both 99.
There you go.
Question.
Yes.
Should the axis of symmetry be
Should the axis of symmetry be
it should be a line, right?
Yeah, it would be a vertical line, correct? This is kind of. Do y'all know what the axis of symmetry is? A couple of y'all asked me this when I came to y'all stable. I'll go ahead and describe real quick. The axis.
That needs to go. 0, 100 is the domain or something.
Yeah, it's something else.
Think
The
0,
axis of symmetry is essentially a line that goes through your
range.
vertex.
That's the range.
So that's what the axis of symmetry is. It's basically a line that goes through your vertex. So in the case of this, or of all all the scenarios, it is a line where it would be like x equals something, and that something would be the same x that you have in your vertex. So if y'all have a tile, it should be x.
Bump it up.
1.5. Should be x equals, if I'm not mistaken. So that would be your axis of symmetry.
Okay, what would 0 to 100 be, class?
So what would 0 to 100 be?
Range.
The range. Why is it the range?
Because it's going from the lowest point to the highest point.
Exactly. It started at 64, right? Launched to 100, and then went back down to 0. So at any time, any time which is your x value, your y value is your height. So it's the list of all possible heights of that function, which was 0 to 100. Thank you very much. Thank you, guys. So let's ask.
You have 10 minutes.
Okay, we're gonna go ahead and give y'all a little quiz. Sorry, class kind of rushed today because y'all's schedule. We have a little bit more for y'all, but we have a little quiz to make sure y'all kind of kept up with what we did. And so go ahead and put all the stuff on your desks under, and thank y'all very much.
I was like,
Oh my god.
Sir.
Y'all need more light, or is the mood lighting okay? Alright.
I like it.
Oh, you
Stop for graders. Please do your best.
guys, we're gonna take this real quick. Give you one more second of your time.
They can
This is kind of for me to see how I did as a teacher. So do your best, but don't worry about it. It's not a grade, but it's to help me realize how, or figure out how I did teaching y'all. So if y'all can do your best, that'd be highly appreciated. Thank y'all very much for letting me come and teach y'all today. You'll have. Let's go. Got like
6, 10, 5 more minutes.
About 9
No,
minutes.
10 more minutes, yeah. If you guys are done, raise your hand, I'll come get it.
Send. Send.
Is this supposed to say or more? Or is that of more?